I've got a gas oil heating installation and it ruins me. The gas oil is so expensive and the prices are rising every day.
The whole system is totally obsolete. We are making most of the electricity with nuclear energy and this is destroying everything. Look at this poor tree. It's dying. We are killing everything. We are making the atmosphere warmer. We are making a big hole in the ozone layer. This is catastrophic. We really need to find an alternative, but I don't see any.
So you tell us today that there's really a big problem.
Yeah, totally.
That's why TV Shopping is offering for today only a special deal. Let's take a closer look on stage right now.
For you and the planet, in this special Christmas edition, Teleshopping suggests you the brand new photovoltaic home custom installation. It includes everything to provide for a 3-person family. The system would produce at least 4,250 kilowatt hours per year. Supplied with all the modules, electronic equipment, counter, it is the deal you were dreaming of.
So, you might be a bit skeptical about the efficiency of bringing photovoltaic modules into your house. Concretely, what is a PV module? How does it work? How can we capture energy from the light? You are right to ask these questions, and we are bringing the answers to you.
For this, we have a special guest on stage, graduated from the famous Catholic University of Louvain-la-Neuve, Dr. Smith, engineer specialized in the photovoltaic.
So yeah, interesting question. So the idea is simple. So first, what is the light? The light has been seen as either a tornado of particle or as a wave. And each of these particles is called photon. Each photon carries a certain amount of energy called quanta, which depends directly from its wavelength.
So all the photons don't have the same energy.
So we've looked at the heart of the phenomenon by solving the Schrödinger equation in a solid. And here is what we got. The electron can only have energies in those ranges. And its energy can go from one range to another if, for example, one photon comes and gives it its energy.
But what influence have photons on electrons? To answer this question, we have invited Monsieur Robert, UCL Shopping Quality Controller. Good evening, Monsieur Robert.
Good evening. In a material, when a photon strikes an electron, it gives him its energy. If this energy is great enough, the electron can be extracted from its atom. It then can be used to create a current. A way to do this is p-n junction. But what is a p-n junction? Photovoltaic cells are often made of silicon, which is a semiconductor of valence 4. But semiconductors don't conduct electricity as well as conductors, because the forbidden gap is relatively high. It's possible to improve the conductibility by inserting impurities in such materials. This process is called doping. There are two kinds of dopings: N-doping, where we use a material of valence 5 to cause an excess of electrons, and P-doping, where we use a material of valence 3 to cause a lack of electrons, as we can see on this figure, where the small orange points are electrons and the big one are the corresponding positive holes. When we juxtapose the two types of materials, we obtain a p-n junction. When this junction is created, the electrons and the positive holes at its boundary reassociate each other, which creates a zone called the depression region, where the electron cannot join the end zone because they are repelled by other electrons. It's the same for the positive holes, as you can see. This engenders a potential difference called the potential barrier.
Oh yes, okay, but what is the relation with the teleshopping panels?
Yes, I'm getting to it. In solar cells, we have N-type material at the top of the layer and P-type material at the bottom. As I said before, a photon can excite an electron. If a photon has an energy greater than the forbidden gap of the semiconductor, it can bring an electron in the condition gap and cause a hole in the valence gap. It's called an electron hole. If there's no p-n junction, the electron, after being excited, would go back to block the hole. But with the p-n junction, the potential barrier prevents the electron to fill directly the hole. This allows us the cell to produce electricity and not only heat. I'm now giving voice to Dr. Smith.
The problem is that for material with low energy gap, there is a lot of energy wasted at thermal energy. And for material with high energy gap, there is a lot of photons that are being ignored by the material. The idea is to put a material with high energy gap on top of a material with low energy gap. This way the photons ignored by the first one, so they have a small energy, won't be ignored by the second one, hopefully. And since the energy is low, there won't be so much energy wasted.
Oh, great!
Now you can buy it.
No. That was the easy part.
There are tons of material. Which one gives the best efficiency? To find this, we plotted the efficiency as a function of the two energy gaps. And what we noticed is that it was just a hill. If we could get the coordinate of the top of that hill, we would get this optimal material. To find them, we used a technique used in artificial intelligence called hill climbing.
Thank you. That will be enough.
So, as you can see, our panels are the best.
Do you still have any doubt?
No way! Here's the opinion of one of our customers.
So I opted for PV panels 3 years ago and it's like already reimbursed.
Definitely, this home custom installation is worth buying. So today we make this special Christmas offer. Get your phone and call us right now to get your installation pack, including the modules, electronic equipment and the counter.
It's Christmas deal.
All of this for only 15,000 euros.
To get your pack now, compose the number displayed on your screen. Thanks to be loyal to UCL Shopping. Enjoy your Christmas time and see you soon.
So what are you waiting for? Save the planet and your wallet!
In a one-horse open sleigh.